The JF-17 Block 3's integration with the upgraded RD-93MA engine is one of the most substantial advancements in the aircraft's development since the beginning of the program. This change is not a minor technical update but a strategic enhancement aimed at solving long-standing limitations observed in the earlier variants of the aircraft and ensuring that the Block 3 becomes a fully capable multirole combat platform with credible long-term viability. The RD-93MA engine offers improved performance parameters, greater efficiency, and improved maintainability, critical for air forces operating in demanding environments or with limited logistical infrastructure. From a technical standpoint, the RD-93MA engine represents a generational improvement over the earlier RD-93. With a thrust output increased to approximately 91 kilonewtons, the new engine gives the JF-17 Block 3 significantly more margin in terms of payload capacity, flight envelope, and acceleration. The increase in thrust, while numerically appearing moderate, results in a substantial difference when applied to an aircraft of the JF-17's weight class and design. This boost in power directly influences the aircraft's ability to take off with higher loads, climb faster, sustain higher speeds, and retain agility during high-G maneuvers. The engine also includes a more advanced digital control system, allowing better engine response, smoother throttle transitions, and precise integration with the aircraft's flight control systems. This results in more consistent engine behavior during dynamic aerial combat conditions, especially when the pilot must rapidly switch between different flight modes, altitudes, or speeds. Such control precision is especially valuable in the context of multirole operations, where the aircraft must handle rapid mission changes, including reconnaissance, interception, and strike tasks, all possibly within a single sortie. The durability of the RD-93MA is improved through the use of enhanced high-temperature materials, revised compressor stages, and a more efficient cooling system. These improvements contribute to extended service life and lower maintenance costs, as the engine components are less likely to suffer premature wear or damage under operational stress. This directly benefits air forces in terms of long-term affordability and fleet availability. Engines with longer time between overhauls (TBO) and more predictable maintenance schedules reduce both downtime and operational costs. Structurally, the JF-17 Block 3 airframe has been refined to accommodate the new engine while maintaining aerodynamic balance and mechanical reliability. Adjustments include changes to the engine mounting system, minor redesigns to intake airflow shaping, and reinforcement of thermal protection materials around the rear fuselage. These changes ensure that the new engine operates at peak performance without introducing structural vulnerabilities or excessive heat stress to surrounding systems. Another important aspect of the RD-93MA's integration is its role in enabling other aircraft systems that require additional onboard power and improved thermal management. The avionics suite, including radar, sensors, and digital flight control systems, draws substantial electrical energy. The upgraded engine's improved power generation capacity allows the aircraft to operate all such systems simultaneously without overload. Additionally, the enhanced thermal design ensures that heat generated from extended use of these systems in high-speed flight is more effectively managed, improving reliability and mission duration. Flight testing data accumulated during the development and initial integration of the RD-93MA indicated a high degree of compatibility with the airframe, with engineers and test pilots noting improved handling at higher altitudes and during rapid vertical climbs. This suggests a better energy retention profile during dogfight-like maneuvers and faster repositioning during battlefield engagements. While specific classified performance figures are not publicly available, the general indications point to improved energy efficiency and better mission survivability. Operational commanders also benefit from the RD-93MA's enhanced digital diagnostics, which provide real-time monitoring of engine health and predict maintenance needs. This reduces the likelihood of unexpected failures and allows maintenance crews to perform targeted inspections and replacements. Combined with simplified engine access and modular design elements, this results in a faster turnaround time for aircraft servicing and improved sortie generation rates, key advantages for sustained air operations. The strategic impact of the RD-93MA goes beyond performance metrics. With the JF-17 Block 3 entering service in greater numbers and becoming a central element in modernizing frontline fighter fleets, the inclusion of this more capable and mature engine supports long-term sustainment and expansion. The use of a proven Russian-developed engine with significant service history provides confidence to current and prospective operators that spare parts, overhaul expertise, and technical documentation are well established. This reduces risk for procurement and simplifies the logistics chain for air forces that are already accustomed to operating engines from the same lineage. In terms of platform maturity, the RD-93MA allows the JF-17 Block 3 to represent a more balanced design, where airframe aerodynamics, onboard systems, and propulsion work in harmony. This is particularly important for nations seeking aircraft that offer versatility without entering the cost and complexity brackets of heavier twin-engine platforms. The RD-93MA gives the Block 3 a critical boost in competitiveness within this specific segment of the global defense aviation market. Over time, the integration of the RD-93MA may also allow for incremental upgrades to the aircraft without requiring an engine change. For instance, software upgrades, new sensor modules, or additional cockpit features that draw more power or impose greater thermal demands could now be added without compromising the aircraft's flight performance. The improved propulsion system also provides the flexibility to support future mission configurations that are still under development or yet to be disclosed. The choice to remain with the Russian engine rather than immediately transitioning to an indigenous alternative reflects a practical and operationally sound decision. While the long-term goal of engine independence remains valid for strategic reasons, the RD-93MA provides an immediately available, flight-certified, and well-understood solution that meets current operational demands. This avoids the risks associated with fielding improvement systems or delaying key upgrades due to developmental uncertainty. The integration of the RD-93MA engine into the JF-17 Block 3 is a major milestone that affects every dimension of the aircraft's capability, from thrust and efficiency to maintainability and mission flexibility. The result is a more mature, reliable, and adaptable combat aircraft that now competes more effectively in its weight class. This propulsion upgrade is not merely a technical refinement but a core enabler of the JF-17 Block 3's role as a frontline asset in modern air forces.